Hi everyone, my name is Arlene and today Zoe and Huang will be discussing the existing test patterns in React. We will be focusing on two main categories. First is the test organization patterns, which deal with how the tests are grouped and structured. Secondly, it's the fixture setup patterns, which deal with how the test environments and data are initialized. All the patterns here are based on the X-Unit Test Patterns book by Gerard Mazzaros. Now let's take a look at the first category, test organization patterns. First, we take a look at the test utility method, which is a pattern that extracts the common test logic into reusable helpers to avoid repetition and improve clarity. You see the act function here. It's a utility from React's testing library that ensures all state updates and side effects are properly processed before we make any assertions. In this test, act wraps the update account function. That means React will apply all the update and finish rendering before we run the assert log function to check the output with the to match render output. This helps keep the test reliable and prevents issues from unhandled async updates. This fits the test utility method pattern because these helper functions encapsulate repetitive logic we would otherwise write in every test. By reusing them, we can avoid um, we can avoid duplication, keep the test clean, and focus only on what we what the test is verifying and not the underlying mechanics. But like any other pattern, it comes with some drawbacks. It can hide complexity behind abstraction, which might make debugging harder. It can also become tightly coupled to internal logic, making the test fragile if implementation details change. And if a utility breaks, it can cause multiple tests to fail unexpectedly, which can be tricky to troubleshoot. So overall, test utility methods are a powerful way to organize and clean up test logic, but they should be used carefully with good documentation and a clear understanding of what they are doing under the hood. Next, we have test case class per class. It's a test organization style where each test file is focused on a single class or module, making it easier to test all of its behaviors in one place. In this example, we have a component called fold that uses an invalid array attributes, specifically array type, which doesn't follow the proper naming pattern. So in case you didn't know, array attributes, which stand for accessible rich internet applications, are used to improve accessibility for screen readers and other assistive technologies. So they have strict naming rules. So this test will check whether React properly warns developers when an invalid array attribute is used. So we'll render the component inside React strict mode and then use the assert console error def function to verify that the correct warning appears in the development mode. So this will fit the test case class per class pattern because the test file focus only on this module's behavior related to invalid array handling. It keeps the scope narrow and makes it easy to locate or update the test when working with accessibility related code. The pros of this test is that it gives a clear focus on individual behaviors, making tests more targeted. It's also easier to spot regressions since each, each test tracks a specific component's logic, and the structure also helps keep tests organized around a single component or module. The advantage are that when multiple modules are involved, failures can be hard to trace since tests don't capture full interactions. There's often redundant setup code across similar tests, and the test files can become large and harder to maintain over time. Overall, this pattern is great for unit level clarity, but less effective for testing interactions across components.
Hi, I'm Huang Feng. I'm gonna start my partner right now. Uh, I'm gonna talk about test organization pattern. This pattern group tests based on how a feature works. So instead of focusing on just one class or file, the test focuses on the whole feature, which might include several components or behaviors. In this case, the test is from React strict mode test file. It starts by creating a container and rendering a class component inside React strict mode. Then it uses set states to update a counter. The key things being tested here is how set state behaves in development mode. This cap test help make sure a full feature works properly under certain settings, like dev mode, and that the final state is what we expect. Um, Test organization has some advantage and disadvantage. Starting with the advance, it checks the whole feature flow, not just a small piece. This makes sure everything works together as expected. It gives us more confidence at the iteration level since it tests how parts work together. And because tests are grouped by feature, it's easier to find the right test when something breaks. But there's still some disadvantage. These tests can be fragile. Even small internal changes can break them. Even if the features still work fine, they also run slower since they usually involve more components. And finally, they can be harder to debug. When something goes wrong, it might be unclear where the problem is because the test covers logic across different components. So while this pattern gives good coverage, it also comes with some trade-offs. And now feature setup. It is about preparing a clean, stable environment before each test runs. This have make sure every test starts from the same point, so the results are reliable and not affected by previous tests. It also prevents something called test pollution, where leftover data or state from one test mess up another. By keeping tests isolated, feature setup make the whole test suite more trustworthy. In React code base, we can see different ways this setup is done. Some examples include inline setup, delegated setup, implicit setup, and suite fixture. Each of these has its use depending on what test need. Now, the advantage and disadvantage of feature setup. Um, Implicit setup, which is when the test setup run automatically in the background. The main idea is to centralize the setup so tests can focus on what they are trying to check, not on repairing the environment. This is done using functions like before each. There are a few advantages to this approach. Each test start fresh, which make them reliable. We don't need to repeat the same set of code in every test. And since the setup runs automatically before each test, it saves time and avoid mistakes. But there are also some downsides. Before each method runs before every test, even when some tests don't need it. That can slow things down or cause confusion. Also, when reading a test, developer might need to scroll up and check the before each to understand starting point. This method works best when the setup is lightweight and applies to all the tests in the file. On the right, we can see the example from React Codebase. Here, the test creates a container and set up a root using before each. So every test inside gets the same setup automatically.
Next, I will be talking about the suite fixture pattern. This pattern creates a shared environment for all tests in a suite, and it is usually set up in a required before or and optional after or to provide consistency. If you look at its code, you will notice it is using before or to create shared environment in a test suite. And this avoids repeating the same set of code and makes the test depend on a known consistent state. The advantage of these tests are it provides a consistent starting point for all tests in a suite, and it runs the expensive setup only once, which will reduce execution time and redundant code. The disadvantages are if we change something in a setup, it can affect all tests in a suite, which might lead to unexpected interactions or interdependent tests. And if one test fails, it is hard to figure out if the issue comes from the test itself or the suite setup. Incorrect cleanup can also cause shared state between tests in this case, which can lead to unstable tests or unreliable test results. This pattern is best used for stateful apps, expensive or global setup that is required. Coming to the inline setup pattern, this pattern places the setup directly within the test function itself. For example, in the code, you will see it is creating the element and the root at the beginning of the test, and it will do some action on it and use expect function to see if the result is returned as expected. Now let's go over what makes this pattern useful. In this pattern, the setup logic is contained with the test itself, and which provides clarity and ease of debugging, and there's no need for us to navigate between files or functions to understand the context. Each test will start with clean state, preventing any shared state issues, and the failure on one test doesn't affect the others. However, it also has a few downsides. When multiple tests need the same setup, repeating it using the inline setup function will add extra work and increase the test time. It is also hard to maintain and increase the risk of mistake because if you want to update the same setup, you have to go around like all place in the function test suite functions to update manually. For complex setups, test functions can become bloated, making it very difficult to focus on the actual test logic. So this pattern is best used for small test cases where setup is minimal and doesn't repeat often. The last pattern is the delegated setup. This function moves the setup code into a reusable function. For example, in this code, you will see the click logic is used while the logic is inside the click function. So what are the benefits? The first one, it provides a reusable setup and reduces the code duplication. The second, it centralizes the setup, so when we want to update, it is very easy to maintain. We just need to update in one place. And it keeps test code clean and let the test focus on the assertion. However, this convenience also comes with some trade-offs to consider. A developer must navigate to the helper function to understand the test setup, and if a bug exists in the click helper function, all tests using it will fail, making the debugging harder. And if the helper function modifies global state, tests may become interdependent. So when should we use this pattern? This pattern works best for the medium-sized test suites where setup is reused often but doesn't need global state management. So let's say about how test organization and the fixture setup is being used in the ReactOpenSource project's test. This is a reference of our research, and thank you for listening.